There we go. There we go. Um, it looks like it's gonna create it. I don't know. I don't know what I did. Okay. 1, 2, 10, 13, 14, 15. See ya. Okay. Let's see. Okay, I'm gonna give up trying to figure out Zoom. I feel like it's not that hard. I just, I like to make things harder than things actually are, I think. Anyone else like that? Okay. Okay, questions, comments, concerns from last Wednesday, our little intro. Anybody? 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 Okay. Let me open my chat so I can see that, and I will keep my participants up, so hopefully I can keep people in my classroom. But there's no guarantee. Okay. Share screen. Screen 2. There we go. And move my peoples over here. My participations over here. And then my chats are over here. Okay. 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 So we are going to look at our Jupyter Hub in person today as we go. We'll do that after. But this week, we're going to kind of go into some advanced Python techniques and talk a little bit about it and brush off the dust um, on your Python that you may have. So don't forget, there are notes posted in Moodle that hopefully will help you going forward. Did anybody use the notes from last week? Were they helpful? Did anybody use them? Yeah. Okay. And they were helpful for you guys? Like maybe a little bit? I think they're helpful just because you don't have to like draw the big pictures and stuff. I don't know. Okay. Well, I hope they're helpful. Um, because I'm trying to make sure that what's in there is what's kind of matches what's in here. Okay. Okay. So data science with Python, that's what we're talking about in this course. Okay. This is not a Python 101. We are going to assume you already have some Python knowledge background. Okay. What we're going to be doing is we're going to be expanding on what you already know and to include some things that you may not have been exposed to, such as pandas, because they are more data science oriented. Okay. But with Python, we're going to look at it from an OOP, an object-oriented approach. It's a modular design where the modules are the objects. Okay. It's a set of related functions, things that are going to be related, that are going to do sort of the same thing, um, have the same purpose, things like that. They may or may not be within a class, but most importantly, it is used for organizational purposes and for reusability and modularity, right? Once something is proven to work and proven to be true, we just use it moving forward. We don't have to keep testing because we know it's true. Ooh, I got people in the waiting room. Admit, admit. Okay. Okay. So that's why we're going to look at things from that modular point of view. Okay. If we're going to start off talking about modules, let's look at the differences between modules versus a package, especially in Python. Okay. So a module, it's an object that serves as an organizational unit. Okay. Whereas a package can actually contain submodules, recursive mo sometimes I need to not hit the mouse button when I'm trying to think. A Python module can contain submodules, subpackages. It's just a way of putting things that are alike together. Okay, modules will have a namespace containing arbitrary Python objects. A package is still a module. Okay, it's kind of like that is a square, a rectangle, but is a rectangle square type of thing, right? Modules and packages both are imported into your Python code. And from there, you're able to use what is available to you. Okay. A module is going to be in a single .py file, whereas a package is going to be usually a directory or some sort of structure containing multiple Python files. Okay. So that's what we're talking about with a module versus a package. Now, there are a few different ways that we can use these modules or packages. We can say import file name if we don't have the .py. Okay, remember case sensitive. So if I create something called my class, I can say import my class if my class.py is the file. Okay. I can also import file name as a nickname. So I can give it a nickname and then use the nickname. And then last, I can say from file name, import blank. So that is going to import a portion, but not the entire function or class. Okay. So those are three different ways that we can do it. So let's see. Python syntax, class name with body, import math. Okay, so here I've created a class circle. I've got some defined functions that are in here, and I'm also importing math. So I can actually import into other Python files or modules that may exist somewhere else. Okay, so for this, I've got math. I called it circle.py. And that's going to give me the understanding of kind of what's going on. Okay. So if my member is public, I'm going to use a normal naming convention. So lowercase, radius, calculate, and area. Okay. So if it's public, so this one right here, I can see that this one on the bottom is public because it is calculate underscore area. Now, if I want it to be private, I traditionally put a leading underscore in the name. And it's just a way for the users to understand what's public versus what's private. And you can very quickly see what's public and what's private. So if this were underscore calculate underscore area, you can see that it would be a non-public. Okay. Again, that's just kind of a naming convention of how we do things. So here I do have this would be kind of what you would see at the beginning of a module. Okay, so pandas.dataframe.from underscore dictionary, data oriented data type, blah, blah, blah. So the module is this pandas So the first one is the module. The second one is the class. So it's a lowercase module P pandas, uppercase D class data frame. Okay. Now, when I do it this way, I do need an instance of self in order to operate. Okay. So just make sure that you use that self so that you can actually use it. Now, the top one didn't need one. Okay. But the bottom one will need an instance. Looking at inheritance, you've got a subclass and a superclass. And what we can say is inheritance gives an is a relationship. So is something a something else? Is a car a vehicle? Is a boat a vehicle? That type of relationship. Okay. The derived class or the subclass, or sometimes called subtype, is derived from the base class or the superclass. Okay. Derived class is said to have derived, inherit, extend. You might have known some of these words in other languages. The base class. Okay, so if my superclass is X, my subclass is Y. Y can do everything that X can do, and then possibly some other things. Okay, so if I say X is a tree, Y is an oak tree. So it's a type of tree, but it's more specific. Okay. I always like the vehicle ones, so let's look at a vehicle explanation because to me, I feel like this is one of the easiest ones here. So I've got a class that's a vehicle. My vehicle has an initializer. It can start, it can stop, and it can increase speed. Okay, that's how I'm defining what my vehicle is. Okay. Now, with that being said, I can define a car, which is a type of vehicle, and a car would have an open trunk and a closed trunk. Okay. That might be unique to a car. Just like in a motorcycle, a whether the kickstand was in or out would be specific to a motorcycle. So trunk and kickstand, I don't want to put them in vehicle because not all vehicles have them. So I'm going to put into vehicle the items that are going to be common amongst my vehicles. Okay. Then in each class that extends it, I'm going to put things that would make that unique. Okay. So a boat might have something unique, right? An airplane might have how many engines. Okay. That's what's going to make it unique. Even when a class does not define a constructor, it in fact does have one. And in Python, it's actually a double underscore. So I apologize that it looks terrible in PowerPoint, but PowerPoint goes, oh, two, I'm just going to make it a big line. So I maybe need to put like a space or something in there. Okay. But it is a double underline, a init double underline. Okay. Every class inherits certain basic classes from an object. Okay. So everything that you're going to create is going to be an object. So it has some that it's going to inherit every single time. A init is one of them. Okay. Right here, a init. Okay. There's some other ones that we're going to talk about. EQ, GT, LE, LT. Okay. There's a few of these that we're going to get a little bit more into, but there is a default for each one of these. Now, what you as a programmer are going to do is override those methods that you want to do something else. Okay, so if I want my initialization to do something okay, that was special and specific all in one word that did not make a real word. If you want to do something specific for your class, you can add it in your self-defined init. So for here, I've got my motorcycle. I want to have a kickstand on my motorcycle because I don't want my motorcycle to fall over, right? So here I'm going to define the double underscore init with a self, right? And it's also going to have the kickstand. So my self.kickstand equals kickstand, and they go in kickstand in or out, but I'm just going to say kickstand. And then it does do a super init. So the super init is going to do the init of the vehicle. Okay, so whatever was in the init of the vehicle, let's go back a little bit. It's going to come up here and do that. So it's going to do self-started, started, self-speed, speed. Okay. What you're basically doing is you're overriding the constructor from the parent, but you can force it to call the parent with that super. Okay. So in reality, I don't need to call the super for the vehicle at all if I don't really want to. Okay. But if I do, I need to do it explicitly with that super init. Okay. Once I do that super init, it has all the functionality of the vehicle from the parent, plus anything I've added to it. Okay, so it works just like other languages. Now, some other methods that are really great to override. Okay, I've got underscore underscore EQ. It's an equivalency. Okay, but it's a special equivalency. What this underscore underscore EQ is actually doing is that it is allowing me to use that double equal sign. Okay, which is really kind of cool. So I can then say, is a car equal to boat, which shows me equivalency, right? So I also have add between my underscores. It's going to allow me to use the plus sign. Okay, so I might be able to say, can I add a car plus a boat? Okay, and what does that mean? I can define what that means. Okay, so for example, if I say a car plus a trailer, that may somehow translate to a trailer hooked up to a car hitch. Okay, but I created the class, so therefore I am going to make the decision as to what addition of my class means. Okay. I can give a length to my object. I can say, what is the length of the vehicle? What does that mean? I have the ability to dictate that. Okay. And that's just like this, the length of the vehicle. Is it a wheelbase length? Is it a passenger cabin length? Is it how many miles can I go on a tank of gas? I don't know. But you get to make that definition. Okay. And then finally, I've got the str, which that is going to be used when you call the print. So creating a string representation of an instance. So if I say print vehicle, what does that look like? Does it print make, model, year, color? Does it print VIN number? Does it print the cost? Does it print the owner? Does it print some kind of combination of those? Okay. So every time you call this print, it wants a string representation of what that is. Okay. Now, if I go back slightly, maybe, there we go. Some of these other ones, GT is greater than. So what am I comparing? LT, or no, yeah, there we go. Less than. So what am I comparing? Okay. So there's a lot of them that we can do in that way. But I always think it's cool to use the equivalency and the add and the subtract to do kind of things that would make sense. If it doesn't make sense, don't override it. Okay, functions as first class objects. So functions are just like any other variable. Okay, you can store functions in data structures. You can pass functions as arguments. You can set values of functions. You can use them in control structures. Anything that you can do with a variable, you have the ability to do with a function. Okay, so a programming languages is said to support first-class functions if it treats functions as it would first-class objects. Functions are nothing more than an object themselves. Okay. So let's say we're going to assign a function. Okay. So I define two functions. Function number one says define, say hello, name, I return hello, and I put the name. Okay. So it's just going to return a string saying hello. Okay. So if I say hello, Chris, it's going to come back and just say hello, Chris. Okay. Now, if I want to define a second function, be awesome, and then a name, it'll say, yo, name, together we are the awesomest. Okay. So be awesome, Gregor. Yo, Gregor. Today we are the awesomest. Okay. So can I create a list of the two functions? So can I create a Python list that is nothing more than function A and function B? Well, I can. So I can now say my list equals the function say hello, comma, be awesome, included in my square brackets, which means it's just a list. So I can create a list that is just those two functions. Okay. I'm treating these functions that I've defined as a variable, just like I create variables, right? Can I call the functions using this list notation? Well, yeah, I can. I can say my list sub zero, and it's going to be the say hello function. If I call my list sub one and send it Thomas, it's going to call the be awesome function, sending it the name Thomas. So it's going to come back and say, yo, Thomas, together we're the awesomest. Okay. So I can assign a function to any kind of data structure that I can assign a variable to. Okay. I can also pass a function. So can I pass a function as an argument to another function? So def going to define greet Bob greeter function, return greeter function, and I'm sending it Bob. Okay. If I say greet Bob, say hello, okay, I'm sending to greet Bob the hello function, the say hello function. So what that's going to do is it's going to return say hello with sending it Bob. So our say hello just said hello with the name. So it's going to come back and say hello, Bob. I'm treating this just as I would a variable. Okay. So the second one, greet Bob. So that's this one that I did up here. I'm going to say be awesome instead. So it's going to return to it a call from Be Awesome, sending it the text Bob. So what you're going to get is the yo Bob together we're the awesomest. Okay. So I can pass a function as an argument to another function. Okay. See how I did that? I think it's kind of cool. I'm a nerd, so it's okay. Okay, returning a function. So this right here is going to, I've got a defined create adder X, and then within that, I defined adder Y, and it's going to return X plus Y, return adder. Okay, so I basically nested a function within a function, which is something that is unique. Okay, you can't do that in C. At least to my knowledge, you can't. Pretty sure you're not supposed to if you can. Okay, so here if I say add 15 equals create adder 15, okay, X now has the value of 15. If I say print add 15 and send it 10, I'm now going to add 10 and 15 together and get 25. Okay. So I'm returning the function back. So it's kind of some things we can do with it. So the last one is something called a function decorator. So here I've got code and I've defined a decorator function. I've defined within it something I call a wrapper. So it's going to print something is happening before the function is called. It's going to call the function, and then it's going to print something is happening after the function, and then basically kick out. Okay. So here I've defined a function, say we, and it says print, and it just says the word we. Okay. So now if I say we equals decorator, which is this one up here, say we, what do we think it's going to do? Okay. It's going to come up here. Something is happening before the function is called. It's going to say we, and then it's going to say something is happening after the function is called. Okay. So it's allowing you to do things before and after a function is called. Okay. So that's kind of cool too. Okay. Ooh. So what is happening? The decoration is happening when I actually set it equal to that decorator. Okay. So the say we points to that wrapper inner function. Okay. And then you return the wrapper as the function when you call that decorator. So if I say the say we, it says it's the decorator wrapper. Okay. That should be a small W. But wrapper has a reference to the original function as funct. Okay. And that's what actually calls the print in that where it says print we. Sorting and lambda functions. Lambda functions, I don't know. My brain doesn't like them, but I like it in theory. If that makes any sense. Anyway, Python can help with sorting if all we want is a list back. So here I have sorted 52314. I can say it'll sort and it'll say 1, 2, 3, 4, 5. Okay. I can also do admit, still admitting people, sorry. I can also come back and say A equals the list of 5, 2, 3, 1, 4 and A dot sort, and it will sort A. 1, 2, 3, 4, 5. So this function will work on any object that I can iterate on. Oh, that's okay, Will. He said he keeps getting kicked out. That's okay. No big deal. It's going to call the LT, the less than function, to compare the results. Okay, so as long as you can iterate on it, it's going to say, is 5 less than 2? No, so it's going to put the 2 in the front. Okay, so it's going to kind of swap things around that way. Now, if I have a class that is a person, and I define an init with a name and an age. Okay, so that's what's going to define a person. I can then use a comparison to compare people. Okay. In this case, I have defined my less than to compare the age itself. Okay. So if I want to compare not necessarily based on their first name in alphabetical order, but I want to do it by age order, I have now defined that if I compare two people, it's based on age. Okay. Here I did an override of the str. So if I try to print a person, it looks readable and it's going to print name and then the name and then age and then age. Okay. So here I have person object. So I've got a list of people. It's going to say list of persons. It's a list of people. So I create a person John who is 15. I create a person Jane who is 12. And I create a person Dave who is 10. And each one of these is an object. Okay. So they each have a name and an age associated. So if I print object 0, 1, and 2, it's going to print John 15 because that's how I specified it in this str. It's It's going to print Jane at 12, and it's going to print Dave 10. Now, I can also do on this list the sorted function because I have defined a less than. Oh, that was a hiccup, sorry. Or what the LT for less than means. So because I defined that, I can say person objects equals sorted person objects. And if I do print the 0, 1, 2 again, the order has changed based on the age because that is what I defined in that LT less than. Okay. So now when I print it, Dave is age 10 and is now first because they're the youngest. Jane is in the middle, age 12, and John is last, age 15 because they're the oldest. Okay. So anything that you create as an object that has an LT in it, I can use sorted to compare it. Okay. Functions and comparisons. So trying to make sure I'm at like I haven't like lost anybody in the notes, which might be me, but that's fine. Okay, functions and comparison. So it will perform the function before doing a comparison. Okay, so sorted, this is sorted. It's going to give me this is sorted. Sorted, this is sorted. If I want my key to indicate that I want to compare it with all lowercase letters, I can say key equals str lower. Okay, why? Because this up here, the T is going to be capital. And in ASCII, capital is always going to basically come first, have a lower number. So that is why when you first do it, it prints out the T, the I, and then the S. If I indicate that I want the key to say string lower, what it does now is it's going to compare lowercase t this to the lowercase I is and the lowercase s in sorted. So in that case, my word this is going to go all the way to the end after the t, after the s, right? Because I is going to come first, then s, and then t. Because I did that, it basically ignores the case of it. Okay. We can define our own functions to retrieve a key. So here I can say, I'm defining a function, get latitude, and I'm going to send it a location. Okay. And what I want to do is I'm going to strip and I'm going to do a split. And then I'm going to return the first value. Okay. So when we send it something, it's a latitude and a longitude. So get latitude, it's going to get rid of the parentheses first. Then it's going to split on the comma and it's going to take the first value. That's why I have the 0. Okay. So I can say now if I want to sort this and this, and my key is going to be equal to the get latitude. Okay. So what it's going to do is it's going to pull out this latitude out of the first one and then pull it out of the second one. So it's going to compare the 34.5 to the 22.8. The 22 is less. That one's going to go first. The 32 is greater. That one's going to go second. Okay. So we strip the parentheses, we split on the comma, and then it uses that first part, the 22.8 or the 34. Now, defining something like this, waste of time. It's very specific. I may never call it again, but I can use what is called an anonymous function. Python calls it a lambda function. Technically, it's an unnamed function. And what you'll see is instead of using the DEF way of defining a function, you're going to use the word lambda. So it'll look something like this, and we're going to look at one in just a minute. But it's going to say lambda, it's going to have the arguments, it's going to have a colon, and then what you want to do. Okay. It's very good for these. I'm going to go back real quick for these really short functions where it's literally a def on one line and a return on the other, those are the ones that we're looking at when we're talking about these lambdas. Okay. You can have any number of arguments, but only one expression which is evaluated and returned. Okay. So I can send it a bunch of different things, but this expression can only be one. You can use your lambda function wherever function objects are required. So as long as you can use a function object, you can use a lambda. Okay, they're syntactically restricted to a singular expression. So again, very important. It can only do one thing and one thing only. But it's going to be really good at doing this whole thing. Okay, so let's take a look. So if I look back at my people that I did before. So if I say sorted person objects key equals, ooh, let's look at this. Lambda. So I'm going to send a lambda function. P, P dot age. So it's going to take in an object person and it's going to return the age of the person. That's what it's going to compare. So that's going to do exactly what we did before. So if I run that again, it's going to say Dave 10, Jane 12, John 15. Okay. Again, sorted if I want to do it on those latitudes. My key lambda L, and then I return L dot the strip and the split, and then the sub-zero. Okay. Because when I did that, it was a single line. So I took this line and I just put it after the word lambda, and it gives me that same answer back. Okay. Example, let's do a couple more examples and then we will look at the Jupyter Hub stuff. So example, tuples. So here I've got tuples, okay? John is 15, Jane is 12, Dave is 10. Now, difference, it's not a person object. Oh, poor Will. It's not a person object, it's just a tuple. Okay, so I did not create a whole new class as a person. I didn't have to overwrite the inits, anything like that. I just threw names and ages in a normal tuple. So I've got a list of tuples here. Okay, so here I want to sort my tuples, and the key I'm going to use is the tuple sub one. Okay, so the 0 would be the name, the 1 would be the age. So this is going to do exactly what that example did before with the people class, because it's going to give me Dave first because he's 10, Jane second because she's 12, and John last because he's 15. Okay, so using the lambda allows me to expand this to tuples. Okay, because with that lambda and the key, I'm indicating which portion of the tuple I want it to use to do the sorting comparison. Because technically, if I put 0 here, it'll alphabetize them. Okay. Here's another example. I've got planets. I've got my planet Earth, and I've got a size, I guess. I've got Jupiter and another size, Saturn and a size, and Mars in a size. So what happens if I type just sorted planets? Well, it's going to sort them alphabetically. So Earth, Jupiter, Mars, Saturn. Okay, what if that's not what I meant? Well, if I really wanted to sort by size, what I could do is add that key lambda in there, send it P, and then planets sub P. Okay, so what that's going to do is it's going to pull out the numerics and put them in size order. So that's going to be different. Okay. Let me see what we have here. Okay, so question. What's up, Amber?
I'm confused how why is it P that sorts them by number, if that makes sense.
It is, and I did write this down, and I forgot where I wrote it because I totally was looking for it. Okay, so what you're sending it is P. Okay, so what you're sending it is planets sub P. So what you're sending is the key and the value associated with the key. So you're going into this looking at one of them. Ooh, sorry, I did not mean to click that. I know I'm not giving a very good explanation because I literally, when I was writing this, I wrote down a better explanation and it's not on this paper that I found because I was kind of confused as myself. You're returning planets sub P. So what I would do actually is I would put this in my Python and put planet sub P or type out planet sub zero and see what it gives you because that's what I did last time. I'm going to clarify that for Wednesday because I know I took notes on this because I literally asked myself the same question. So I'm sorry. I don't have a good answer now. Any other questions that I hopefully can answer? I feel really bad that I can't answer that question because I knew you were going to ask. Is a placeholder or the actual input? Is what a placeholder or the actual input? Oh, is P a placeholder? Yeah, I think it's a placeholder. Because if you go back, when you're looking at this, so your argument would be P, and then you're returning the position within the list, right? So technically what you're getting, so you're getting something here, and then you're returning the position within that. But I know it has to do with how we are defining this group here. There we go. So let me, oh gosh, I have too many things open on my screen. I swear I'm graduating to the point where I almost need like a third screen. So Python, because I believe it's putting it as a data dictionary entry. Because I'm thinking that's how you do, if I remember correctly, that's how you define a dictionary entry, a quote unquote dictionary entry. Well, that didn't work out well. Let's see, Python dictionary example. Dictionary with examples. Let's see. Yeah. So this is technically a dictionary, okay? So there is a, sorry. There is a connection between the elements. So the Earth and 6371 is an element. So Earth is the key. The value is what comes after the double dots, okay? So I've got my keys and I've got followed by my values. So what you want to do is you want to go through and remember how I call something in a data dictionary, right? I can call it by using the word Earth. Okay, so I'm calling planets and I'm calling Earth, I'm calling Jupiter, I'm calling Saturn, I'm calling Mars. And what that gives me is the number back. It's because it's a different data structure. Did that help? Yeah, we're not in a tuple for this. We are actually in a dictionary. Yeah, dictionaries always kind of confuse me because you actually don't call it by 012, you call it by whatever the key is. Okay, cool. Cool, cool, cool. Okay. Any other questions, comments, concerns? Otherwise, I'm going to jump on over, maybe if I can find it. Hmm, I may not be able to find it. To my Jupyter Hub. Let's see. Jupyter Hub. Oh, there it is. I did find it. Look at me. Okay, so here's my Jupyter Lab. Okay, so once you log in, did everybody get emails about the Jupyter Lab stuff? On like how to log in? Do you guys know basically kind of is a dictionary a hash map? I I I don't know the answer to that question. Yeah, I don't think it is. I mean, kind of. Okay. Okay. I see everyone saying yes and no, so it looks like it's like a combo. Okay. I don't remember. Oh, basically it was for the hash map. Yeah, okay, gotcha. It's all good. My brain's just fried. It's fine. It's been a rough Monday, man. Anyone else have a rough Monday? I was like, oh, it's gonna be a nice Monday. No, it's been a chaotic Monday. Okay. I will ask a question then if you guys, okay, I can't move things, so I can't save the changes. Lord have mercy. I'll ask some questions to see if you guys are gonna get an email. If not, I'll get back with you guys on Wednesday. Um, because I can't, hold on, let me see if I could do this. There we go. Okay. My share was like holding my thing hostage. There we go. Okay. My share was holding everything hostage. Okay. Okay. It says you can use your student accounts from the Linux machines. That makes sense to you guys? If not, I'll figure it out. I don't know what I do with my, there we go. Yeah, that makes sense. Okay, cool. If that makes sense to you, and I'm happy about it. Okay, so in there, there are going to be assignments. So if you use the web-based, it's assignment list. Here, the first one up there for you guys is project one. So you can go ahead and say fetch. Then you can actually click on it and get to the file and what it's asking you to do. Okay. So all of the quote unquote projects, I think there's one like every other week, will be in these notebooks in that way. Okay. So if you guys, project one's already up there, take a look at it, see if you have any questions, if you have any comments. If you can't figure something out, let me know. We're going to work through this together. I think it's the regular notebook stuff like you guys had before. But if not, we're going to work through it. Okay. And next time, Wednesday, we are going to finish up the rest of this stuff. And hopefully, We're going to be Python ready and ready to go with statistics the week after. How does that sound? I don't know. I can't get excited about statistics. I don't think anybody can get excited about statistics.